Right, so here we're going to take a look at a rational function that we can find the integral using long division. So we know we can use long division when we've got the degree on the top is greater than the degree on the bottom. And that's exactly the case that we've got here. We've got an x to the third on the top and an x squared on the bottom. So we are going to take our x to the third and divide it by this x squared plus 6x plus 9. So we do have to leave placeholder zeros for all the possible powers of x that we can have that are less than to the third power. So we'll have a 0x squared plus a 0x plus a 0. And then we, again, kind of just take a look at that first term of what we're dividing by and look at our first term in what is being divided and say, all right, what do we need to do to make an x squared into an x? Well, we need to multiply by another x. So if we do that, we're going to get x cubed plus 6x squared plus 9x. So this expression is what's going to go here in our long division. And we always take this multiplication and then we subtract what we've got here. So we've got to do opposite signs for everything. And then this x is going to go right here over our x term on our division. And then we start combining like terms. We actually subtract. That first term should always cancel out. That should happen every time. If it doesn't, you need to change what you multiplied by. Then we get 0x squared minus 6x squared, so we get negative 6, and 0x minus 9x, so we get negative 9x there. And then we bring our plus 0 down. And so again, now we're just looking at this negative 6x and looking at our x squared and saying, all right, how can we turn an x squared into a negative 6x squared? Well, if we multiply through by negative 6, we are going to get that. So we'll get negative 6x squared minus 36x and then minus 54. So again, this expression is going to go right here. And I just leave all the signs the same because then at this point, then I say, okay, I have to subtract everything. So that's going to change all of my negatives to a positive. So this is us subtracting each term. And that's the same thing we're doing up here. And then we write our minus 6 up there, what we multiplied by, up on the top of our, division symbol that we've got there. And again, now we combine like terms. Those first terms should cancel. They do. And then we get, let's see, that's going to be plus 27x plus 54. Okay, so now we're sitting at that we got x minus 6 from doing our division plus our remainder over what we divided by. Now, what's not quite as nice on this one as on the other long division problem that we did is that we still need to break up this fraction. And this is where we now use that partial fraction decomposition. And this is generally called PFD because, again, math people, we're lazy. So we take 27x over 54x, or over 54, sorry, and that denominator actually does factor. That is x plus 3 squared. So this is good. This has got like all the things. This has got repeated factors. It's got long division. It's got partial fraction decomposition. So when we've got that repeated factor, we have to write it there both times as a single factor and as a double factor. And then we multiply both sides by that least common denominator. Whoa, can't write a 3. There we go. And so cancel, cancel, cancel one, cancel both. So we get 27x plus 54 is equal to ax plus 3 A, and then plus B. This one's really not bad at all because we get 27 is equal to A, and then we get 3A plus B is equal to our constant term. Well, we know that A is 27. And then, so B is going to be, oh goodness, when we multiply that and subtract, we get negative 27. So A is positive 27, B is negative 27. So, all right, what did we figure out? So we started with x cubed over x squared plus 6x plus 9. And then from our long division, we got x minus 6. And then we had our remainder. From our remainder, we broke that up with partial fractions. So maybe we'll do this in 2 steps here. This is what we got from the long division. Then we did partial fraction decomposition on what we had left there. So our x minus 6 stayed x minus 6, but then we found out that a over x plus 3 and b over x plus 3 squared split up that fraction we were left with. And now we have an integral that we can do. We get 1/2 x squared minus 6x plus 27 natural log of x plus 3. And we've seen this a couple times now, this negative 27 x to the, or x plus 3 to the negative 2, we use the power rule on that. So we get negative 27 times negative 1, x plus 3 to the negative 1, then plus our constant. And then, just in terms of making it look nice, and I really don't mind if you write it at that sort of not looking nice format, but I kind of can't help myself to write that as positive 27 over x plus 3 plus our constant.